So let's take a problem that appeared on JEE Advanced in 2013, and the question says find the number of local maxima or minima in the function fx equal to 2 mod x plus 2 minus modulus of mod x plus 2 minus 2 mod x. So to analyze this particular function, we'll do it in the graphical way to check out for the local maxima and the minima. So to draw the graph of this particular function, we have a very interesting process and a very innovative one. So for that, we first of all find out the critical points in the function, and the critical points are the points where the modulus function will change the course of its path, and that can be easily found out by equating the quantity within the modulus by 0. Like in the first case, we are getting x equal to 0. Then in the second case, we are getting x plus 2 to be equal to 0. So the value of x is equal to minus 2. And then we are putting the entire quantity within the modulus to be 0. So mod x plus 2 should be equal to 2 mod x. And that will lead us to two possible cases. That is, x plus 2 is equal to 2x, or x plus 2 is equal to minus 2x. So for the first case, we can see that x will come out to be 2, and in the second case, x will come out to be minus 2 by 3. Okay, so these are the solutions that we are getting, or these are the critical points that we are getting where the modulus function will change the course of its path. So what we're going to do is that we'll be highlighting these 4 points to draw the graph of this function. So let's do it in this way. Suppose let's plot the real axis. So this is the real axis, and let us consider the points which are the critical points. That is, let's go for minus 2, then let's go for minus 2 by 3, then let's go for 0, and finally we'll be going for 2. Okay, now what we'll be doing is that we'll be calculating the functional value at these points. Okay, so we can do that very easily. Like f of minus 2 can be calculated from the given function. Like the function, we can see that on putting x equal to minus 2, we'll be getting a value that is, let's check out, 4 plus 0 minus modulus 0 minus 4. So f of minus 2 will turns out to be 0. So here the functional value will lie. Then for the next critical point, that is minus 2 by 3, so we can see that it will become 4 by 3 and plus, okay, just putting x equal to minus 2 by 3, we'll be getting 4 by 3 plus 4 by 3, that is 8 by 3, because the third part, the whole modulus, will come out to be 0. So at minus 2 by 3, the function will return 8 by 3. Okay, so suppose somewhere here. Then on putting x equal to 0, we are getting the functional value to be 0 plus 2 minus modulus of 2 minus 0, that is, again, it is going to be 0. So at 0, the functional value is 0. And on putting x equal to 2, we will be getting the functional value to be equal to, so f of 2 will become equal to, on putting x equal to 2, let's check out, 2 into 2, 4 plus 4, so 4 plus 4 minus modulus of 4 minus 4, so f of 2 will come out to be 8. So it will be somewhere here. So once we get these 4 points, now we can easily join the points by straight line, because you can see that the graph is surely going to be a linear graph. That's for sure, because we are having linear functions. So to get the graph of the function, we can easily join the points, connect them by lines. Okay, because we are sure that the graphs are going to be linear in nature. Okay, so we have already got the graph here within the interval minus 2 to 2, but beyond minus 2 and 2, we need to do an extra analysis out there. Like the extra analysis is going to be, we can see that when x will be very, very large, think about minus infinity, what will happen at minus infinity. So we can see that in this case, as x tends to minus infinity or plus infinity, as x tends to plus minus infinity, what is happening to the function? The function is tending to, we can easily check out, it is coming out to be 2 infinity plus infinity minus modulus of infinity minus 2 infinity. Okay, because these are very, very large quantities. So ultimately modulus of infinity minus 2 infinity will come out to be infinity, and this large quantity and this large quantity will be cancelled out, and ultimately we'll be having a value that is very, very large. So we can see that when x is tending to plus or minus infinity, this function is going to actually a very large value, that is infinity. So we can simply continue the graph here, and we will be extending the graph up to infinity by linear nature. So okay, so this gives a rough estimate of the graph of the function, and we have innovatively got the graph of this function. And once we have innovatively got the graph of this function, now we can see that we can predict about the local maxima and minima, because we can easily check out that this is going to be a local minima, this is going to be a local maxima, and this is going to be another local minima. Okay, but this critical point is not having any extrema. That's quite clear from the graph. So in total we are having 3 local maxima or minima. So answer for this question is going to be equal to 3.